Okay, once again, welcome to the new video. This will be after I have finished the wireless controller positioning, and we have stated that in the converged architecture of the wireless control provisioning, you can even have a new device, which is a switch of the 9300, I'm sorry, catalyst switch from Cisco, and it can have an embedded controller. That's what the previous video is all about, controllers. Right now this video is all about access points. Access points have modes. You can buy an access point, just an access point, and when you operate it, you operate it based on a mode that you desire. And those modes, each one of them have special functionalities. The first mode is called the local mode. This is the default of a lightweight access point. When you buy a lightweight access point, not the individual, I'm sorry, autonomous access point. When you buy a lightweight access point and you operate it, by default, it operates under the local mode. In the local mode, what happens? There will be a cap wrap to the controller. Everything passes through the cap wrap. All of this have been discussed before. And if the cap-up fails, just like I've mentioned 2 videos ago, all clients will be disconnected. All stations will be disconnected. Mode number 2 is the bridged mode. This allows an autonomous access point, that type of access points that does everything by itself and doesn't need a controller, to wirelessly connect actually to using about a wire, can be using a wire to connect as a client to a lap, to another lightweight access point. If I have this guy here, this autonomous access point, I can, if maybe if it's like I want to operate it in some mode that I just wanted to receive connection from another access point, not to do the config by itself, not to manage by itself. For some cases, I can use a wire and connect to an LAP. I must buy an LAP that has 2 Ethernets, so one Ethernet for you and the other will go back to the switch and then to the controller. This is the bridge mode and has some connections. Mode number 3 is the flex connect that I have just talked about in the previous video, when you have like in the, I believe it was in the second architecture type. Okay, the flex connect. Flex connect was in the previous video. It was this guy over here, Cisco Flex Connect, for making the lightweight access points have more privileges and more functions to authorize you and allow you to connect even if cap-up fails. Those are one-to-one local bridge and flex connect. Mode number 4 out of 7 modes that I will discuss is the monitor mode. This guy generates reports and statistics of the entire network, the entire wireless network, the entire access points in the same domain, and send them back to the wireless controller. So you can buy like 5 access points, 4 of them are local serving, and the 5th one is the monitoring one. This one is looking for all of you are working such frequencies, clients, data. Good, then I will send the report to Mr. WLC. This is the 5th guy. It's the same model, the same design. He's their brother, but he behaves like a monitoring one. Okay, so this is the 4th mode, the monitoring mode. 3 are left to talk about right now. The sniffer mode, this scans a specific channel and sends the scanning report to the wireless controller. This scans the available channels that the other access points are broadcasting using it actually, or other access points are streaming using those channels, to know the channels that are used right now in this PSS or in this domain, this coverage area, the overlapping that's happening, or maybe no overlapping happening, and it's all sent back to the controller. The controller doesn't do something actually. Nothing, doesn't take this benefit to itself. This is for you, so that when you access the controller later, you will see that in BSS1 there is an overlapping in channel 4 because access point 3 is streaming using channel 4. Let's change the design or the channel so that overlapping will not happen again. This is for you, these statistics and monitoring for you. Mode number 5, is it 5 or 6? I believe it's 5, yeah, which is the sensor mode. Sensor mode do some SSID tests and sends the report back to DNA center. This is a big guy. This is a big mode where it doesn't communicate with the WLC. It does, but it doesn't send the reports to the WLC right now. It will send it to the DNA center that I have talked about in chapter 1. The DNA center is the WLC of the network. It's a controller of your network. I don't care about the device type, routers, switches, firewalls, wireless cables, wirelessly, fiber optics, etc. This is the big guy that has a license of, if it was $88,000, maybe I have watched like an INE's video for that, and I believe Brian McGann said that cost about $88,000. Yeah, okay. Just skip that. Okay, so don't use the sensor mode if you don't need it. Okay, after that you have the mesh mode I have talked about before, when you wirelessly make one of the access points connect to the another access point, so that this guy will work just like an extender. But in the mesh mode, this is the main guy, that this is the real access point that has a cable goes back to a switch. So this is the first one who has really internet. In the mesh mode, you can have multiple access points behaving as a mesh, because you just can't extend cables for a long distance, like for 100 meter, and in every 20 meter you can just place a wireless access point without cables. So every 20 meter I must place an access point, another one, I'm sorry, etc. What's happening is that there is a mesh connection between them. Maybe the others are even closer, so they are maybe like connected this way or connected this way, etc. This depends. This is why it's called mesh. In this type of connection, multiple connections are occurring, but it's not a full mesh, just like chapter 1. It's only a mesh. So a frame might travel multiple mesh nodes before reaching the LAN, because this guy here, when a mobile phone or any wireless device connected to it sends something to this access point, it will send it back all the way to the root access point, the RAP, root access point, and all of those guys are called mesh access points, the MAPs. Okay, a mesh node, the MAP, use adaptive wireless path protocol, AWPP, to determine the best path back to the root access point. So this guy, instead of doing this thing, it can know that the closest way to the root will be this way. So this is just some an entirely automatic topology and operations that will happen when you operate the mesh topology, and you don't need to worry about them. These are seven, yes, 1, 2, 3, 4, 5, 6, and 7. Yeah, I can remember there are 7 types of operation modes. I have now some notes to talk about. Some access points have a PoE port in behind and an AUX port. You can bundle or aggregate, combine these two ports to form a higher bandwidth data interface. You remember port channel in chapter 2, in the end of chapter 2, I have combined, bundled or aggregated two fast Ethernet ports of 100 megabit speed and formed one new 200 megabit speed port channel. You can do that in an access point just in case it has only a single Ethernet port. You can combine with this single Ethernet port. You can combine the AUX, the auxiliary port, to have even a new port with a higher bandwidth. This is note number 1. Note number 2, the controllers have some type of a port that's called a service port or a management port in the back. This port can have an IP address assigned to it, and this IP address is used for the graphic user interface design remotely to access this device. Just in case you are wondering how should I access it remotely using a controller, but I think no, we'll talk about it in a minute. Okay, note number 3, to bundle or aggregate ports in controllers and in access point. Some things need to be noted here. If it was a wireless controller that you have, and there is some ports in this controller, and you want to bundle them together to form a single port channel, high bandwidth port, you can use the command channel group mode on from the switch side. In chapter 2 we used LACP, mode active or passive, and in the previous CCNA there was also mode PAGP, which was this guy. What is PAGP? This one. LACP for active and passive, PAGP for auto and desirable, and there was an option, fifth option, that was called on in the switch. I haven't talked about it, I haven't used it in switches. It's used in routers for layer 3 bundling. Okay, maybe I've talked about it in the end of chapter 2, but on in switches, where does it be used? It's used if your ports in the switch are connected to a controller. okay, then you use on. Why? Because by default WLC doesn't support or know anything about LACP and PACP. So just to bundle things from the switch side, make it on. From the WLC side, you can see there is a GUI saying that these ports, you hit, maybe you can check the boxes of two interfaces, click bundle, that's it, they are bundled. You have no idea what's happening behind the scenes. This is the simplicity of GUI. But if it was an access point and you want to bundle some ports, it's either to use on, just like the WLC, or a LACP, okay? But only with local access points. If the access point was performing in the local mode, which is the LAP that we have talked about previously in the beginning of the video, not the autonomous access points. So briefly, if you have an access point, a LAP, a lightweight access point, you can bundle some of its port, and when bundling some of its ports, either be bundled to use the LACP from the switch side or to use the on. This is for note number 3. For note number 4, access points and controllers are just like any other networking devices that you have worked with. They can be managed by CLI, and CLI can be accessed either by console or remotely by Telnet or SSH. Or can be accessed using GUI, and this happens or done by using HTTP or HTTPS from a web browser, actually, of course, because this is a graphic user interface that you can access remotely to a device, and we will see it in the pack tracer in moments. Right now, after I finish with note number 5, authorizing access can also be done using AAA. I have talked about this before, or I haven't. I will talk about this in the security. In the security, I should have removed this note actually for me, because there is a lot of speech about AAA 802.1x in the security video that will be upcoming in a few videos. Okay, it's in the next video actually. So that's it. These are only 4 notes that I wanted to talk about, and for this GUI and HTTP thing, Spectator actually do provide us with a wireless devices section, and they are right there. These are the wireless devices. The 4th option from the left, we can have either a Meraki. This guy here is a Meraki MX65W, a security appliance. We can hit enter, click and we can zoom in to see there are some Ethernet internet ports and some other ports clear to here, and also there is an IC adapter. I can just take my IC adapter and connect it to this guy and it will work. It's like a home router. Okay, it's this one. This is the Meraki. The other option is to have a lap PT, a lightweight access point. When we hit a click and zoom in, we can see that what's happening is that only there is a reset button to factory default reset, an AC adapter, and a PoE. Just in case you couldn't connect an AC adapter, you can connect a PoE cable back to a switch, and this single Ethernet cable will operate the device and will send some information. This is good, thank you. I can have another model which is 3702i, a lightweight access point. I can have some controllers. This is a WLC PT controller, and also another model which is the WLC 2504. Okay, some home routers. This is a home router, thank you. And some other devices are clear in the pack tracer. Maybe just to see one of them, this is a controller that have like only a console port. You can see this is the word console here, and some data ports are there, and in those data ports, port number 3 and 4 are have a little note says that they are PoE. That's good. Okay, thank you. I have this other WLC in here. This guy, maybe one of them was able to be accessed using look at this one. How simple is it? It has an AC cable and a gigabit Ethernet port. That's it. We are done. Okay, it doesn't have anything more. But I believe this one, yes, this one, the WLC 2504 in the pack tracer comes already configured, just like other wireless devices from other vendors. Comes already configured with a management IP address of 192.168.1.1 and the subnet mask of 255.255.255.240. How to make use of that? Let me tell you that I will bring my laptop to the backtracer and I will connect a cable to this guy. Now it's connected, and you have in the management, actually if I just click here and went to the management in the real life, you will buy this controller in a package, and on the package there will be on behind there is saying that the management IP address is 192.168.1.1 on slash maybe like 240 will be, how much will it be, slash 28 maybe, or slash 27, we'll see that in moments. And also the default username is admin and the default password is admin, just like your home router when you buy it from the market, the same thing. But the idea is that right now I will give to my PC an IP address of the same range of this guy, so that me and him can be on the same network and I can access it through GUI. So for my PC, I will go to desktop and I will assign 192.168.1.2 slash, I'm sorry, 240. That should be enough. Go out, let's go to the web browser, and from the web browser I will try to access this controller 192.168.1.1. Go. I can see we have some activities going here and I need to wait a bit. Take this one off the screen, do some fast forward, because I have tried this before and it took minutes. Yep, yep, thank you. After fast forwarding a bit, you can see right now. Okay, this is the welcoming. Yeah, that should be good for you. Okay, create an admin username. I will make the best username. Okay, create an admin password. I have some restrictions here, saying that password must contain at least 6 characters, uppercase, lowercase, numbers, and special characters. Okay, it's a lot. Okay, then we make it admin, and the admin A capital DMIN 123 and the hash. That should be enough. A capital DMIN 123 and a single hash. Start. Welcome to the GUI of a wireless controller. Okay, the first thing, you can set up your controller system name. We need to give it a name for this one. Let's make it, call it III, the WLC, triple I WLC, the country of, okay, this is an emulator, so we can change it by why it's Kenya. Okay, no problem. Baghdad, where did you know that I'm from? Baghdad. This is the time and the date. Okay, some management IP address for the controller. This is for accessing remotely. We can make it on the same thing, but /10, and I can make the subnet mask also to 40, and I will make the default gateway is the IP address of a router that I have in my network, which will be 100. And the management VLAN, we can assign it later from a switch using VLAN 10. IP address and gateway must be in the same subnet. IP address and gateway must be in the same subnet. Oh, I'm sorry, /100. Of course, it will not give me. Let's make it 15. Okay, next I can enter the SSID. Maybe we can make it triple I SSID. How to security using WPA2 personal or enterprise. What are those? Those are things that I will discuss in detail in the upcoming video. The WPA in all versions with all modes, personal and enterprise. Passphrase is the password for the SSID that people will try to connect to me, which will be 123 123 123. Confirm the passphrase 123 123 123. Okay guys, will be on which VLAN? Have something, invalid password. Okay, 123 123 123, and again. Okay, now it's done. The management VLAN, I can change it, but I can't do it in a real device. Hit next. RF parameter optimization, make it an off. Hit next. These are all the settings that you want to apply. Are you agree? If you are, then hit apply. Yes, the device will reboot right now. The WLC will reboot this guy, so that the config will be applied. So actually, thanks to Packtracer that it did give us some brief overview regarding this case. Okay, the AP will be the same, the access point, just like the WLC. It's a GUI, simple GUI. It will tells you what you need initially to make this device operating and serving everyone, and that's it. That's all you need to do with anything GUI actually. So this is the end of this video talking about access points, and in the Packtracer we have access a controller, not an access point, but just to make an example. In the upcoming video, the chapter is almost done and ended. In the upcoming video, we'll talk about security, and after security, the chapter 6 will be done. So I hope this was clear. Just in case it wasn't, please inform me down below in the video comments section. And also, I hope to see you again in the upcoming video of the Wi-Fi security. Goodbye.